Hi there, welcome back to Think Tank Online Learning. So in this video, we're going to look on Cauchy Integral Theorem. Okay, so Cauchy Integral Theorem is a very powerful theorem, especially in complex variables. Okay, so given a question, and we actually have two questions, question A and question B. And I want to use the Cauchy Integral Theorem to evaluate these integrals. Okay. Okay, so what does the Cauchy integral? Okay, so what is the Cauchy integral theorem? So the Cauchy integral theorem said that if fz is analytical, it only works on analytical functions. Okay, and remember that on complex variables, if f of z over z minus z to the power n plus 1 dz. So to evaluate the integral of this one, we're not going to do some crazy or complicated integrals. What we're going to just do, we're going to say 2 pi I. In some textbook, we're going to find 2 pi j here. It doesn't matter. I just represent that y, it's imaginary, over 2 factorial f to the power n of z naught. Okay, so if n is 1 here, that means we're going to have f prime. That is 1, so that means we're going to differentiate once. If we have 2 here, that means we're going to also differentiate twice, and so on. So I'm going to solve this equation, these questions, question A and question B. Okay, so I'm going to start by question A. So on question A, I want to evaluate this integral, and are given that the region we're looking for, which is C, and you should know these are the line integrals. Okay, these are the line integrals in complex variables. So C is a circle of absolute z is equals to 2. So what does absolute z equals to 2 mean? Okay, and I'm assuming that you are familiar with complex numbers. Okay, so if we are given that absolute z is equals to 2, this represents a circle, and what is on the equal sign is the radius. So the radius is going to be equal to 2. So what about the center? So this is same as saying z is minus 0, 0. So that means the center is equal to 0, 0 if only have z here. So the center is going to be equal to 0, 0. Okay, so before doing something crazy, I'm going to start by just drawing this circle. So I'm going to draw it right here. Okay, so this is my imaginary part and this is my real part, and I'm going to draw a circle, and they say that the radius of our circle is 2. So that means the distance from here to here is 2, and we have negative 2 here, we have negative 2, and we have 2, and I'm going to shade the region. Okay, so now I know the region which I'm concerned about. So this is the region C. Now I'm going back to my integral. Okay, so let me look at my integral. So my integral, we have the path is closed, and we have z squared over z squared plus 9, and you have dz here. Okay, so now if you look at the Cauchy integral theorem, we don't need z squared. We don't need z squared right here. Okay, so we just need z. So how are we going to achieve that? Let's start by factorizing. Okay, so if you factorize, you're going to have the integral from c z squared, and if you factorize here, we're going to have z plus 3i times z minus 3i. Okay, I'm assuming that you are familiar with factorizing this one. Okay, so in complex variables, so I times I are going to have a negative, and if we expand this, are going to get this one. Okay, so now let's look at the denominator. We're going to solve, we're going to find the singularities. Okay, so I'm going to say z plus 3i is equals to 0. And so for z, and z minus 3i is equals to 0. So that means z is going to be equal to 3i, and z is going to be equal to, yes, is going to be equal to negative 3i, and yes, is equals to be positive 3i. Okay, so let us look at our circle. Where is 3i? So 3i is going to be somewhere here. It's not going to be in the region. And what about the positive 3i? It's not going to also to be equal in the region. So what does that mean, or what are you going to do? So according to Cauchy, it's going to be simple. We have nothing right here. So what are we going to write? Okay, so this is what we're going to write. We're going to say the integral of c z squared over z squared plus 9 in this region is going to be the integral of 0 dz. We're going to have 0. Why? Because all our points are outside this region. Okay, So that means this function is going to be analytical, but it's not analytical outside the region. That's why we're going to have 0. So now we're moving on to the next question. So on this question, we want to, our C is a triangle with vertices. Okay, so we're given a triangle, and here we're given a circle. Okay, so what we're going to do, so first let's start by sketching the triangle. So we're given that these are the coordinates. This is 1 minus 4i, 0, negative 2 minus 5i. Okay, I think we can do this. So for the second part, I'm going to write part 2, which is right here. I'm going to start by sketching the triangle. So I'm going to sketch my imaginary part right here and my real part. Okay, so let me write I'm going to write real. Okay, like this one. What are my coordinates of my triangle? So we have 0. Okay, that is the origin. Okay, we know 0 is right here, and we have 1 minus 4i. So I'm going to move 1 unit here, and I'm going to move 4 units right here. So I'm assuming that my 4 is right here, and I'm just a sketch. I'm not using the scale. And we have negative 2 minus 5i. So I'm going to move 2 units to the left and 5 units right here. So I'm assuming that negative 5 is right here. Okay, after that, I'm going to draw my triangle. So I'm going to join this point first, and I'm going to join this point and this point. Okay, like this one. And after that, what I'm going to do, we need to shade our region. Okay, so now that we have our region, let's look at our integral. Okay, so you say that our integral is z squared over z squared plus 9. So we want to evaluate z squared over z squared plus 9 dz. And we said we factorize first if the power of z is not 1 right here. So we're going to have z squared over z minus 3i z plus 3i. Okay, and we're going to have dz here. Okay, so we said that z is equal to 3i and z is equal to negative 3i. Okay, so let's look at z equals to 3i. So if we look at z is equals to 3i, we're going to see that 3i is somewhere here, and that is not in the region. So let's look at z equals to negative 3i. So z equals to negative 3i is somewhere here, and z equals to negative 3i is in the region. Okay, so now we have z is equals to negative 3i in the region. That implies that z plus 3i is region. So this means this function is analytical except at this point. Okay, so now what are we going to do? Now we're going to use the Cauchy Integral Theorem again. Okay, so we're going to say, so this is going to be the answer. Let me write it here. So we're going to say the integral of c. Okay, remember that we said z to the z plus 3i is in the region. So that means you don't need z minus 3i here since it's not in the region. So I'm going to say z squared divided by what is not in the region. Okay, so that is z minus 3i. So I'm going to say divided by z minus 3i all over z plus 3i. And I'm going to write dz here. Okay, don't make a confusion here. You divide with what is not in the range. Okay, so what I did, I've just changed the appearance, but the value of my function is still the same. If we say z squared over z minus 3 divided by this one, you're going to spin. We're going to spin, and we're going to change the division sign to the multiplication sign, and we're going to come back here. Okay, so that means, let me put this in brackets. Okay, so now I can write that my fz is now z squared z minus 3i. Okay, and my z value is going to be my z naught. Okay, So remember we have z minus 3i. So if we have z plus 3i, that means my z naught is negative 3i. Okay, like this. Okay, so now let's evaluate the integral. Okay, but we don't have n. N is equal to what? Remember, if I put a bracket, you're going to see we have 0. The power is 1. So that means, since our formula is n plus 1, so that means n is going to be equal to 0. Okay, so let's evaluate our integral right here. So we've said the formula. I have the formula right here. So we've said, let me try to do this. Okay, so we've said what is the formula? So the formula is going to be, okay, so let me just write it here. The integral, okay, so the integral of z squared over z, okay, it's z minus 3i divided by z plus 3i dz is going to be equal to 2 pi I over n factorial, and we have 0 factorial, and 0 factorial is equal to 1. Okay, now going to have f of z. So f of z, what is f of z? We've said that f of z is equal to z squared over z minus 3i. It is z is equal to negative 3i. Okay, so 0 factorial, it's 1, so we have 2 pi I right here. And what about here? So if we have z squared, that means we're going to have 9i. We're going to have negative 3i squared. So negative and negative, we're going to get positive. 3 times 3, we're going to get 9. I times I, we're going to get negative 9. Okay, and here we have z minus 3. And remember that our z is also equal to negative 3. So we have negative 3i minus 3i. Okay, like this one. And this is going to 2 pi I times negative 9 divided by negative 6. Okay, we have I here and we have I here. And as you can see, if we say 2 times 9, we're going to have 18. 18 divided by 3, we're going to have positive 3 pi. Okay, like this one. So this is our answer. Okay, so now we're moving to this question. This one. Okay, which looks more complicated, but it's not complicated like you think. Okay, so we're going to do the same. We want to evaluate the integral. Remember that we're given a triangle. So these are the coordinates for our triangle. It's e to the power I pi upon 4, negative 2, 1 minus 2i. Okay, so let me write it here. This is question B. The integral of 5z2 divided by 81 minus z to the power 4 dz, and we have c. And they've said that c is a triangle with e to the power I pi upon 4, and we have negative 2 and 1/2 minus I. Okay, so first I'm going to start by sketching this coordinate, but I don't know the value of e to the power I theta, so I'm going to change it. Since this is the Euler's formula, I can write, let me just give you a quick reminder. Remember, e to the power I theta is going to be equal to r cos theta plus I sine theta, like this one. Okay, so that means e to the power negative, or actually it's positive, pi upon 4. I is same as saying we have 1 here, cos pi upon 4 plus I sine pi upon 4, like this one. And this is equal to root 2 over 2 plus root 2 over 2 I. Okay, so now we can sketch Again, sketch the triangle. Okay, so I'm going to draw my imaginary part, and I'm going to draw the real part like this one. Imaginary, real. Okay, so I'm going to start with -2. You can start with 31, but I'm going to start with -2. So I'm going to assume that my -2 is right here. So this is the point which I like. And I'm going to go to 1/2, which is here, minus I. So I'm going to assume that my -1 is here. So this is -1, and this is going to be 1/2. So this is also going to be my point. Now I'm going to √2/2. So √2/2 is something like 0.7. So that means it's going to be somewhere here. I'm going to write √2/2. This is the positive √2/2 in the real part, and also positive √2/2 in the imaginary part. So I'm going to assume that it's here. Okay, so don't worry about the scale, it's just a sketch. And after that, I'm going to join these two, actually the 3 lines together. So from here to here, and here to here, and here to here. Okay, and you are told that it's oriented anti-clockwise. So you can write this direction if you want. So this is the anti-clockwise. So this is the region which are concerned about. Okay, so now let's go to our question. We said for the Cauchy integral formula to work, we just need c here, not z to the power 4. So let's factorize. Okay, so if we factorize, let me write it here. Okay, so we have, let me change the color. So we have 81 minus z to the power 4. Okay, so if we treat it as 81 minus x to the power 4, we're going to get 9 minus x squared and 9 plus x squared. Okay, like this one. And 9 minus x squared, we know that this is 3 minus x, 3 plus x. Okay, so what about here? Okay, so remember my first example. So this was my first example. We have z squared plus 9, and this is what we have right here. So we're going to get 3i plus z and 3i minus c. Okay, so this is set. Okay, so I'm going to write it here. I'm going to write that the integral of c 5z squared divided by, I'm going to write 3 minus z, 3 plus z, 3i plus z, 3i minus z. Okay, like this one. Okay, let me just use arrow to draw. And I'm going to write the z right here. And if we solve for z, what do we have? We have 3 minus z is equals to 0. And we have 3 plus z is equals to 0. 3i plus z is equals to 0. 3i minus z is equals to 0. So that means z is going to be equal to 3. And z is going to be equal to -3. And z equals to -3i. And z is equals to positive 3i. Okay, so let's look at our region. Z equals to 3, it's somewhere here, it's not in the region. Z equals to -3, it's not in the region. Z equals to -3i, it's also not in the region. And z equals to positive 3i, it's not in the region. Okay, so if that's the case, this question becomes easy. Okay, but what I want you to try, I want you to try 9 minus z to the power 4. Okay, so if you try 9 minus z to the power 4, you're going to see that most of your points are going to be in the region. Okay, so for this one, according to the Cauchy Integral Theorem, we don't have any point that is inside the that is inside the region. So going to, we can now write 0, 5z squared divided by 81 minus z to the power 4 dz is going to be the integral of 0 dz, and this is equal to 0. Okay, so that's all. So thank you for watching, guys.